Greetings. My name is Clivin Geju, a student of registration number 19BCE1480, a computer science student from VIT Chennai, and this video is for the Natural Language Processing Digital Assignment 3. So in this video, I will be talking about term frequency, inverse document frequency, otherwise known as TF IDF. I will be explaining what it is. I will talk about how it is used and explain it with an example, and also show how you can implement this concept in Python. So, what is TF-IDF? So, TF-IDF, like I said, stands for term frequency and inverse document frequency. It is a statistical measure that evaluates how relevant a word is to a document in a collection of documents. So, this is done by multiplying two metrics. The first metric talks about how many times the word appears in the document, and the second metric is it tells you the inverse document frequency of the word across the set of documents. So it has many uses, most importantly in automated text analysis, and is very useful in machine learning algorithms for natural language processing. TF-IDF was invented for document search and information retrieval. It works by increasing proportionally to the number of times a word appears in a document, but is offset by the number of documents that contain that word. So, words that are common in every document, such as this, what, if, all will rank low even though they appear many times, since they don't mean much to the document in particular. Now how do we calculate TF-IDF? So the TF-IDF for a word in document is multiplying the two metrics. So the term frequency of a word in the document is the first metric, and the second metric is the inverse document frequency of the word across a set of documents. So there are several ways to calculate the term frequency, which is the simplest, being a raw count of instances a word appears in a document. Then there are ways to adjust the frequency by length of the document or by the raw frequency of the most frequent word in the document. So for the inverse document frequency, I said it was by calculating for a word across a set of documents. So this means how common or rare a word is in the entire document set. The closer it is to the number 0, the more common the word is. This metric can be calculated by taking the total number of documents, dividing it by the number of documents that contain the word, and calculating the logarithm of it. So if a word is very common and appears in many documents, the number will be close to 0. Otherwise, it will approach 1. So multiplying these two numbers will result in the TF-IDF score of a word in a document. So the higher the score, the more relevant that word is in a particular document. So to put it in mathematical terms, I'll show you how you can calculate the TF-IDF. So now let me take an example of 3 words just for simplicity. He is a good boy. She is a good girl. Boys and girls are good. Now first what we do is we only take the relevant words that is needed from this 3 sentences. So we have good, boy and girl. So these will only be the relevant words for our example. So he is, she is, and are, that and all is disregarded because they are very common and you see them in all the sentences, so we're not going to talk about it. So now let's just make a small table showing how many times the words occur. So let me just label them as sentence 1, sentence 2 and sentence 3. So he is a good boy will be the first sentence, she is a good girl will be the second sentence, and boys and girls are good will be the third sentence. So the words that we will be considering is good, then we will be considering the word boy, and then we will be considering the word girl. So now in sentence 1 we see that good and boy occurs, so we know they occur once. Then in the second sentence we have good and girl, so we have this like this, and then we have boys, girls are good. So what we do first is that we will be breaking down the word boys to the singular form. We will be taking the root word and not the word as it is, as boys and girls are plural. So we will be taking the root word. The root word for boys is boy and the root word for girls is girl. So we will be only considering those, the root words. So and then when you take that into consideration, you can see that all of them occurs at least once. Now to calculate the TF IDF, it's a simple fraction. So so for term frequency, you're just saying the formula will be the number of words or number of the specific word that you want to search for in the sentence. So number of specific word in the sentence in sentence but by total number of words in the sentence. I apologize for bad handwriting, but so so in our case it would be so now if we were to consider this, now I'm going to calculate the TF IDF TF metric. So it's the same this thing. So I'll just extend this over here like this. So for the TF metric for good would be 1 by 2 because there are two words, good and boy, and it occurs one out of those two times. So I'll just write here sentence 1, sentence 2, and sentence 3 so you can get better reference. So the word here is good, the word here is boy, and the word here is girl. So we now know that good occurs once out of the two words that we are taking from the first sentence, and here also boy occurs once out of the two words that we consider from that sentence. So girl would be 0 because there isn't any the word girl is not there in the first sentence. Similarly, for the second sentence, good and girl occurs once each, so we have a total of two words. Good happens one out of those two times, and girl happens one out of those two times, and boy will happen 0 times because there is the word boy is not there in the second sentence. Now for the third sentence there is a word of each, boy, girl, and good. So the value would be 1 by 3 for each case. Okay, so now this is how you calculate the TF metric. Now to calculate the IDF metric, the formula would be let me just write it down here. So first it would be the log value. So first, so it'll be number of sentences, total number of sentences, total number of sentences, and then divided by number of sentences containing that word. So number of sentences with word, with the specified word, I mean. So like now if you want to look for the IDF metric for good in sentence 1, we will okay, I will let me erase this and then I can show you give you a better idea. So so we know this is for good, this is for boy, and this is for girl. So uh, now we have to calculate the IDF value. Sentence 1, sentence 2, sentence 3. It's the same. So this will be good, this will be boy, this will be girl. So here it will be log of. So there are total number of 3 sentences in this case. So it will be, so the numerator will be 3. The denominator will be number of sentences containing the word good. So the number of sentences containing the word good would be 3 as well, because it's there in all the 3 sentences. So it will be 3 by 3. Now for the word boy, I'll just type here boys and girls, so it will be a bit better to understand. If I don't mention the word good also, it should be okay, I suppose. So for the word boy, it will be log of, numerator will be 3 as usual, and divided by, so there are 2 sentences which uh, contain the word boy. So actually you can disregard this, we're just doing this once. um, there are 2 sentences containing the word boy, so it will be log 3 by 2. So now the same thing also will happen with the word girl as well, because there's only 2 sentences out of the total 3 which contain the word girl. So it would be log of 3 by 2. So once you solve this, the fraction, and then you find the log value, and that is your final result for the IDF metric for the words good, boy and girl in the 3 sentences. So finally, to find the TF IDF value, what you have to do is multiply the 2 terms. So you multiply, so since we have a 3 by 3 matrix here and we have a 3 by 1 matrix here, you have to do matrix multiplication of the 3 by 3 matrix into uh, the so you multiply each of this value to each of the term and you get your result. So that's how it works. So log one is 0. So you're gonna get 0 for over here for all these 3 terms, and for these 2 columns you're not gonna get log 1. You will be getting some fractional values. So like I said before, if the number is close to 0, it means the word is like one of the most common words you will see in the document. So in our case, since there's the word good in all the 3 cases, you will get the value of you will see that the value is 0 by multiplying the 2 factors. So now that I have talked about what TF IDF, let me tell you a bit about its applications. So it's useful in many ways. So one example is information retrieval. So TF IDF was invented for document search and can be used to deliver results that are most relevant to what you are searching for. So imagine you have a search engine and somebody looks for the player named this popular NBA player named LeBron James. So, but you search only for LeBron. So the result will be displayed in order of relevance. So that's to say the most relevant sports articles and will be ranked higher because TF IDF will give the word LeBron a higher score. So it's likely that every search engine that you use, like Google, DuckDuckGo, all will use TF IDF scores in its algorithms. So another example where you can use TF, where you can see TF IDF being used is keyword extraction. So how is that possible? So the highest scoring words of a document are the most relevant in the document, and therefore they can be considered keywords for the document. So that's just how it is. So now that I've talked about TF IDF properly, let me also show you now how you can use it in your in Python. So now, so in this example, we are importing the libraries that we needed. So we have the pandas library, and we'll be using the tfidf vectorizer from the sklearn library. So we'll be just working with 2 documents here. So let the document A contains a sentence, the man went out for a walk. The second document contains the children sat around the fire. So machine learning algorithms, it won't work with this, TF-IDF won't work with it directly. So it must be converted into a vector of numbers. So we implement the bag of words technique here to split it into a set of words. So that's what we do here. We do document.split across based on each spaces. So what we do is we split the words in the document based on the spaces, because that's how you identify words. If you were to what do you say, write a sentence and you want to split into different set of words, this is the only way to do it. So once you do that, you can see here I have made bag of words for document A and bag of words for document B. So you can see the man went out for a walk, and for the second one also it's coming the same. The children sat around the fire. So you do that. Now by casting the bag of words to a set, we can automatically remove the duplicate words. So that's why we're using a unique word set. So after doing that, when we run unique words as the variable, you'll see around children 5. So this is also, as you can notice, it's being run displayed in alphabetical order from A to Z. So then what we do is now we'll create a dictionary of words and their occurrence for each document in the corpus. So you're like a collection of documents. So that's what we do here. So you're accounting. So how many the number of words from the document A that is in the dictionary. So that's why you're making a separate set of a number of words A. So you can see that the ones that occur in document A will be given the number 1 because it occurs once, and the ones that's not in the sentence A will be considered 0. So the same way for document B, whatever words are in the document B will be accounted for, and whatever is not will be given the value 0. So in this case, you can see the word the is occurring twice, but for document A it occurs once. So now that you do that, it doesn't account for noise. That's the other problem with bag of words. So certain words are used to formulate sentences, but they don't add any semantic meaning. So example would be the word the. So you can't deduce anything about that particular word. Only that you can notice is that the word the exists in the document. So comparatively, if you look at the word good, awesome, bad, dreadful, miserable, superb, splendid, you can notice that these words are of, it gives a positive rating or it gives a negative rating, or a positive sentiment or negative sentiment, another word. So comparatively, you can see the word the does not give you any significant meaning. So all these useless words are referred to as stop words by use. So here what I'm doing is I'm using the natural language toolkit to provide you what all the stop words that exist. So you can see that I, me, myself, we, us, and also the word, yeah. So all these will be considered is the list of stop words. So when building a model of understanding text, you'll see a lot of stop words being reduced. So that's another strategy of to score the relevant of important words using tf idf. So now we use, in this function we define the define how to compute the term frequency. So like I said, so the tf idf formula was number of words of the number of word in the required word in that sentence divided by the total of number of words in the sentence. So that's how you do it, and then you return the value. So we do it on each document, for each document, document A and document B, and then for document A you can see the values, and then for document B these are the values. So then the next what I do is we would define a function to compute the inverse document frequency for the words. So here what we do is we find the log value of total number of words in the sentence divided by total number of sentences which contain the word. So that's what we're doing here. So this will give you the so, and then we just do it once, because in the example as I showed, you can just do it once because you're considering all the sentences or all the documents in this case into consideration. So, and you can also notice that the word the has been given the value 0, which means to say that it is the most common word occurring in both the sentences, and log so since there are two sentences and in both the sentences it occurs once, you'll get log of 1. Log of 1 is 0. So that's what you get here. And then finally what we do is we calculate the tfidf, and that is just by doing multiplication. So you just multiplying the TF and IDF for each word, and then you save it in separate variables, and then you print it out. So as you can see, for the document A, you're going to get some zero values because because it shows that it's existing and it's common in that document. But for other words that are not there in document A, you'll get such values close to zero, but not exactly zero, because from earlier cases we can see that these words don't occur in the document because they are in document B. So when you see document B, you're going to see like an opposite. See, so for the word walk, you can see a value, but in document B, you'll get value 0 because that word is in document B and not in A. So basically, what you can understand from here is that these words which are given the value 0 is there in document A, and you will find that it's like a common word, and the same applies for document B. So whatever has the value 0 in it, you will be getting your you will find that word in that document. So we can also use directly the tfidf vectorizer function to, if instead of what I have done shown so far is the manual implementation of tfidf, you can also do it directly by using the tfidf vectorizer function, and you will be getting the same result. So you will be getting same if not similar result. So now if you see for the word fire, you're getting almost the same. Then for the word children also you're getting almost the same. So you can notice that we are pretty close when we do it manually, and comparing to using the tfidf vectorizer function directly. So with that, we have come to the end of the video. So in this video, I have talked about what the tfidf is. It stands for term frequency and inverse document frequency. I have told you how important it is in natural language processing. I have revealed what the formulas that can be used for tfidf and how it is calculated. I have given an example with 3 sentences showing how tfidf is calculated, and I also showed a code of implementing tfidf and how you can calculate it manually, or if you want, you could directly use the tfidf vectorizer function provided by the sklearn library. So with that, I'd like to end the video. Thank you for watching.